Hey, welcome back. I'd like to use what we've learned about time series to get a better model for forecasting what's going on with COVID-19. I'm not especially hopeful that I am going to be able to come up with a better time series model. Now, the reason is not that the time series is faulty or the data is faulty, it's that the situation is continuing to evolve. The usual assumption when you're fitting a regression to anything is that the data or the sample that you're looking at is stable. But the whole point of fighting the pandemic right now is that we are making the data and the sample unstable. Every time we flatten the curve, to use that overused phrase, we're changing the underlying regression that we might fit in the data. So this means that in practice, the residuals are likely to be negative a lot of the time, especially on the most recent data observations, as we um, pull away from that regression constantly by changing and improving our behavior. So doesn't mean it hurts to go and do it, just means I'm not thinking I'm going to get any huge insights from this. So, huge insights toward the disease. I hope you get huge insights about the econometrics from this. So, I've copied over the Italian reported death data and I've extended this to April 5th down here, okay, which is the day I'm recording this on. And I'd like to estimate a bunch of time series models, okay. So, what I am going to do is take logs of A1, or excuse me, A4. So let me call that log A4. And then I'm going to do log of A4. And I'm going to create my lags going down this way. And I'm going to create 3 lags, like so. And copy these values down, or copy these formulas down. What did I do there? Now we're not going to be able to do an AR3 model with the data like this. Okay, Excel does not like the missing values up at the beginning. Now the way that autoregressive value models work is every time you put in a lag, you lose an observation from the beginning of the data set. Everybody's aware of this. It's a known shortcoming. And so you always kind of have this trade-off that it's easier to start with a large model and strip it down to its essentials than it is to start from a small model and build it up. But if you start with a large model in time series, you lose a number of observations off the front. So I have poked around a little bit with this in the background, and I think a third order autoregression is as far as I want to go with this. So that would be from this observation on down. Okay, so I'm going to take these right here and copy the to themselves as values with a paste special, Alt ESV, and then I'm going to overwrite these this label here, okay, with I'm just going to call this y and y t minus 1 and y t minus 2 and y t minus 3. Okay, and maybe later on I'll put a better label in there for that. Okay, and then I want to run a regression. So it's going to be a third order autoregression, meaning it's got 3 lags in it, starting from right here. And I want to go through March 13th, which is the last day we were in the classroom. So this is as if we were forecasting on that day with the data we had that day. Or we're not forecasting at this point, fitting with the data we had that day. So I run the regression, and I'm not even going to clean this up. What I want to look at is, are my variables actually important? And what I see is that the third lag seems to be unimportant, the t-statistic is small and the p-value is high. The second lag seems to be unimportant for the same reason, but the first lag seems to be important. So I'm going to do this sequentially. I'm going to go back and drop out the third lag, okay? And to do that, I'm going to redo what I did before, because I'm trying to preserve as much data as I can. Whoops. Copy that down a couple rows. And then, oh my god, I keep hitting the wrong keys there. Copy that down, copy that down. And that doesn't seem right. Because I didn't do the cells right. Or I didn't save them properly. Okay, copy that down a couple rows, copy that down a couple rows, and now I've got this many observations that I could actually use, so I'm going to copy those down. I think 46 is where that ends. And right here again, I'm going to put my labels. They're going to be one row up right now, so we'll call that YT and YT minus 1 and YT minus 2. And I don't expect my second lag to fit well, but I just want to check that for completeness. And again, we're going to go through the 13th, which is in row 25. And I'm all set up. Run my regression again. Not even going to clean it up, just going to go straight and look at the t-statistics. And again, I do see that that second lag is insignificant and the first lag is significant. So now I'm going to go back and recreate my data set again. This is mostly because Excel is kind of cumbersome with this and a little bit hyperactive sometimes. So I'm just going to redo it each time carefully so I can eyeball it and make sure it looks okay. And now I'm going to put my labels here. And now I know that this one is going to be okay because I've done it in the background before. So I'm just going to make this label here equal to B3. And I'm going to write this one as equal to lagged B3. So that's lag reported deaths. And run my regression. And run that down to row 25, which is the 13th of March, where we left off in class. Like so. And click OK. And there's a good regression that I can work with. Okay, so I'm going to make it wide enough to hold my labels. I'm going to center everything. I'm going to reduce the number of digits it's shown to 3 or something like that. And I'm going to add a label. So this is a regression of logged reported deaths on a single lag. Okay, for Italy from 2002-22, whoops, to 20-03-13. Now I go down and look at my regression, and my single lag is highly significant. The p-value is very, very small. Whoops. Okay. I look at my confidence intervals, and while the confidence interval of this estimate is close to 1, it is still distinctly below 1 unless I want to use a really, really high confidence interval, which I don't. I think 95% is just fine here. And I'm not surprised with this because if it was equal to 1, we'd expect the number of deaths to trend off towards infinity. Um, Now, when I did this in class a month ago and updated about 10 days ago, I did assume that it had a unit root. But that's mostly because I was covering unit roots at the time, not because I necessarily thought that was the best model for the data. Okay, now that I get this, if we look at this, I've got a root that's significantly different from 0 and less than 1, and no trend term in here. So this is actually a case 3 model in what we did in the book. Okay. Now with GDP, I developed that and said case 3 leads to case 4 leads to case 5, but here I don't see any sense in which restricting the coefficient to be 1, which would get us to case 4, is actually warranted. So I'm thinking I may have gone a little bit too far in modeling that in class as if it was an example of case 4, and I may get a better fit with case 3. Okay, now I need to actually fit and forecast my data. So here's my data over here, and my fitted values then, okay, would be, I gotta come down here and look at my dates. I've lost track of my dates. So there's March 13th right there. I'm just going to put an underbar under that so I realize. So we estimated on the basis of this sample up here, and I want to forecast this out into the future. Now the cool thing about an autoregression is that I can use the information in this period to forecast the next period. Because if we think about what the fitted value is, the fitted value is always the intercept there, okay, plus the slope there times the lag, but the lag is in the cell right next to me here, so that's R25. Okay, so that is my fitted value for this period. My 7.12 is pretty close to my 7.14. Okay. And now I want to go and make sure I put absolute references into those coefficients in the other spreadsheet, like so. And now here's the cool thing. I can actually copy this down a row, and it's still a perfectly legitimate fitted value. And the reason is the only variable on the right-hand side is the lag. And this is now the lag in one period out in the future outside of my sample, but because it's a lag, I actually know what that is before I get there. So I'm always capable of forecasting one period ahead with an AR1 model without requiring any information that I don't actually have already. Okay, so it's already forward looking. Okay, now there is kind of a cool thing that we can actually do. Okay, there is a function in Excel that will do simple regressions. Rather than going through that regression tool, you can use this thing called linest, okay, which is just linear estimation. You can probably imagine that. And it's going to ask for some y's, which I'm going to give to it. These are in Q5 to Q25. And it'll ask for some x's. I've got those, R5 to R25. And I just hit enter, and I got 0.954221. Now if I go over to my regression here, that's actually that coefficient that's right there. Okay, so I can get that in a cell by itself. And I can also construct the intercept from that. Now for this, if you don't know this, you might need to go to an econometrics book or a first semester stats book, but the intercept from a regression that has a single right-hand side variable is the average of the stuff on the left-hand side, so that's in Q5 to Q25, minus the slope, which we just estimated in T25, times the average of the x variables, which are R5 to R25. Run that in and I get that 518922, and guess what? If we go over here to the regression, that's what we got as well. So it only does this for single variable on the right hand side regressions, but it's a cute little formula to have in your bag of tricks. But the nice thing is now I can take this formula and re-estimate it at every step along the way. Okay, now what do I mean by that? Okay, let me take this formula and I'm going to put a $ in front of the first row, okay, in Q, and in the first row in R. And now when I copy that formula down a single row, okay, it extends the length of my series going down here. Okay, so that means I could do this in kind of a rolling sort of way where I get an observation, or excuse me, where I make a 1 period ahead forecast, grab the observation, re-estimate the alpha and the beta, forecast 1 period ahead a second time, and keep going down the road with that. I need to make this one copyable as well. So again, all I want to do is fix the very first cell in those averages. And if I've done this correctly, these should be close, but a little bit different than the ones immediately above them. Okay. Now, the way that I created this thing here, okay, is I went back to the values in the other spreadsheet. But now I have those values right here in one cell above. So I'm going to change that from sheet 6B17 to T25. Or excuse me, U25 is the intercept. And change this to T25. And I should get the exact same value, and I do, the 33551 that I got before. Okay, except now if I copy this down, it will use this piece of information that I just added. Okay, so remember to recalculate these. I was going 1 period in the future. So I forecast 1 period out, then I add 1 period of data, then I forecast again. Okay, so I'm using the estimates of the line from 1 more period and the lag from the current period, which is actually the one that was observed a row up. So I haven't used any material that I didn't have before. And I can copy that down, and again, it's pretty close. Copy this down to the bottom of the data set, and I now have a series of rolling 1 day ahead forecasts of where the epidemic is actually going. Okay. All right, so now can I do something kind of cool with this? Okay, I want to take my dates, so those are in column F. I'll bring those over here. So F5 is my first one that I forecast. I've got my log of reported deaths in Q5, and I've got my 1 step ahead forecasts in S5. And before copying that down, okay, remember this one was not a forecast, that was just kind of a test, so I'm going to delete that out. And I'm going to copy all this down to April 5th. I want to take out these zeros because I'll just make my graph a little bit messy. And so I'm going to call this my date, obviously. This is the label I already had in Q4. Okay, and then this, whoops, is my dynamic forecast. Okay, done one step ahead. And now if I graph these out, I'm going to get, hopefully, if it works, a better looking forecast than I did the other day. Now, this is kind of small, so let me put it in its own sheet. And let's get rid of the clutter. Okay, so I'm going to get rid of the grid lines. And I'm going to change the actual data to a series of points. So I always like the triangles for these. Okay. And I'll make them smaller so they're more distinct. There's going to be a lot of points here. And no line for that at all. Okay. So here I have that set of triangles, which has been the number of reported deaths in Italy. So that's kind of what we've been doing before. And the red line is similar to those 5-day ahead forecasts we were doing before, except it's now 1 day ahead and it's dynamically updated. So that's why it's not a line. It's actually kind of a series of connected line segments. And it's difficult to actually focus in here on what we've got, so I am going to reduce the scale of this axis. I don't really like to do that, but as long as I've, looked at it once and decided that it was necessary, I'm going to go ahead and do that. Okay, so I'm going to make that a 7 and this a 10, like so. And here we see the performance of the Italian authorities, okay, as they try and fight the epidemic. This is an improved forecast over what I did with the 5-day ahead forecast from case 4, because those were kind of assuming that behavior didn't change for those 5 days out, whereas this is assuming every day is an improvement, and therefore we can sharpen my estimates a little bit. And it also does not suffer from the problem that the previous model had in underfitting over at the end here. This is a true underfit here because I keep updating 1 day at a time. And you can definitely see here that over the last 5 or 6 days, the Italians have started to come in consistently under their 1 day ahead forecasts. If we go back to the data sheet, okay, we can actually look at these 1 day ahead forecasts and compare them to where we are in the data. And the last time that they actually underperformed their forecast was back on the 27th of March. So they have now had 9 days in a row of beating their forecasts, which is a good thing. And if we go back 9 days, I think that's probably this one right there, okay? Or possibly this one right here. Yep, it's this one right there. Okay, that was the last time they were under. Okay, you can kind of see here, excuse me, the last time they were over. You can kind of see here that the way that this was trending, it was going to go up in that direction a little bit lower, and they got this spike here, but they got that spike under control, and now they're starting to consistently fall underneath of this. Okay, except how quickly can they actually flatten the curve? I mean, you can see here that the curve is flattening, but by how much? We really don't know. Now, I can come back to my data and guesstimate here, okay? And you know what? I actually can continue to forecast out into the future here if I wanted to. What I would do if I was going to forecast out into the future is I wouldn't have a lag to put in for next period's data. So what I would do is put in this period's forecast as the lag rather than this period's observed variable. So it would be more of a static forecast going out, but I could do it. But what I'm thinking is that probably wouldn't help me very much because we would continue to be overshooting what is going on here. I think the best thing that we can do is kind of come over here and look at how quickly things are changing here. So I should have left myself a space. I didn't. I'm going to go back to the left-hand side here and call this R48 minus R47. So my differences are off to the left, not off to the right. Okay. When we last looked at this in class, the number of deaths in Italy was going up by approximately 20% a day, talking about doubling every 3 or 4 days. Now it's down to 3% per day. That's a huge improvement, but remember 3% growth per day means the situation is still getting worse. It's just not getting worse rapidly. But you can see that these growth rates, they're dropping. So I'm going to actually take another difference here, okay? And so take the difference of the differences. So we're going to call that R48 minus R47. Oops. Minus 47. That'll get it wrong every time, won't it? And this gives us a sense of how much it's going down every day. So here down minus 0.01, minus 0.008, minus 0.002, minus 0.001 again. You get a sense here that this is dropping a little bit every day. So if we go back, I said it was 9 days since they had a bad day. Okay, this was the last day right here where the forecast was below the actual. So I'm going to go to the first good day, March 28th, and take the average of these things. And that average is listed down here, minus 0.008. So let's think about if we were going to do minus 0.008 off of this. So I'm going to take R48 minus 0.008. Okay, and go like this. And maybe one more. And whoops, I didn't need to go one more because these are negative. This makes me think that Italy is going to peak right in here. And it doesn't like that. So what did I do here? Equals y48 plus 1. This makes me think, now this is kind of a guesstimate here, is that Italy is looking at actually getting their deaths to peak and plateau out around April 9th or April 10th. So about 5 days out is when they're going to get that flat. Okay. Hopefully. Okay. We'll see. Okay. Again, I don't expect this model to fit perfectly. I don't think it's an excellent forecasting model because the data is constantly changing, but it definitely gets us a sense that Italy is very, very close to the end of the worst part of their epidemic. All right, that's enough for today. I will see you tomorrow. Bye.